So we're given a graph and we're given a chart. And remember that this would only be one piece of one of the free response questions. And this particular one is so easy. Even if you don't see how to do it right away, you'll see how easy it is once we do it, and you'll never forget how to do these. This one would only be worth 1 out of the 9 points, and then the other ones would be worth more. So I'll give you guys just a minute to read through it and figure out the answer, and then we'll talk about it. So take 1 minute and look at this, and then we will come back to it. And you should be able to do this one without a calculator. This would be a non-calculator problem. All right, so we're given a bunch of information here. We got the graph, we got the chart. We know the function is differentiable twice, which means we could find its derivative and find its second derivative. It says that it's always increasing. Most of that stuff doesn't matter to us for this part of this problem. It might matter to other parts if if we had other parts of this problem right now. But what it's asking us to find is an approximation for the derivative of r prime, 45. Get my pen to work here. So we're looking for r prime of 45. And so all we're going to be able to do is find an approximation, because we're not actually given a function here, like an explicitly written function. All we can do is approximate this value. And so we remember that a derivative is an instantaneous rate of change. And if we're trying to approximate that, the best way to approximate an instantaneous rate of change, if we can't just take the derivative, would be with an average rate of change. So our approximation, I'll do that in a different color. Our approximation should be an average rate of change. Everybody good with that? With that concept that we approximate the derivative by using an average rate of change, or by just using the slope formula. So we could pick any intervals, but they'll always want you to pick the interval that most closely surrounds 45. So we'll choose the interval from 40 to 50. And all we have to do is do 55 minus 40 over 50 minus 40. Right? There's your y values, and there's your t values, or your r of t values and your t values. Find the slope. That's 15 over 10. We could simplify that down to be 3/2, and it specifically tells you to indicate units of measure. And anytime it tells you to indicate units of measure, it means that you will not get the points if you don't do that, or it means that there is a specific point associated with the units. So most likely for this problem, you get 1 point if you write 3/2 gallons per minute, or gallons per minute squared. If you leave off the units and just have 3/2, they probably will give you 0 out of 1. If this might have happened to be a 2-point problem, where 1 point was associated for the 3/2 and 1 point for the units, but my guess is that it's just 1 point total for this problem. Any questions on that?
Why is it minutes squared?
So our original function is gallons per minute. And so if we differentiate, we're looking at how does gallons per minute change per minute. So it's gallons per minute, or gallons per minute squared. And if you think about gallons per minute and then divide that by minutes, right? Minutes over 1, flip the bottom fraction and multiply gallons per minutes squared. Does that make sense?
Yeah.
Okay, cool. Any other questions on that? All right. Problem 2 here. We're going to look at a limit. And so we're given a function. We're also given the derivative of that function. And we're asked to find the limit as x approaches 0 from the right of that function f of x. So why don't you guys take a minute and see if you can come up with what that limit should be. All right, it looks like we might use L'Hopital's rule because it's natural log of x over x, and that's one that, you know, if it's going towards infinity, we need to use L'Hopital's rule. But what we really need to do is just first plug in the 0. So what happens to natural log of x as we approach 0 from the right-hand side?
Goes towards negative infinity.
Goes towards negative infinity, right? That's the graph of natural log of x. It goes towards negative infinity. And what are we dividing that by? We're dividing it by x, which is 0 from the right. So that's a very small positive number. You guys agree that's a very small positive number if we approach 0 from the right? So if we have a very large negative and we divide it by a very small positive, what should we get? What happens if you take a number and divide it by something very close to 0?
It just gets larger.
It gets even larger, and since we're dividing by a positive, it should stay as a negative. So we end up with negative infinity. Did we need this information that was given to us right here?
No.
Nope, not at all. Now it's possible that if there was parts B, C, D to this question, we probably would have used the derivative at some point, but they didn't ask us for anything in this part that required it. And you want to be extra careful not to just go straight into L'Hopital's rule. Like if you had tried to use L'Hopital's rule, what's the derivative of natural log of x? That'd be 1 over x, and the derivative of x would be 1. So this would just be 1 over x as we approach 0 from the right, which would be what?
Positive infinity?
Positive infinity, right? And so we don't want to do that because this is not one of our indeterminate forms. We will not do that. And this is not indeterminate. Everybody good? So make sure you plug in and are careful with what that value is. Everyone good? All right. Let's skip ahead. I'm going to move forward to this one. We're going to come back to the third one here in a second. So we're looking at the curve x squared plus xy plus y squared equals 27, which is an implicitly defined equation. And we want to know if the tangent lines to the curve at the x-intercepts of that curve are parallel to each other. And they want us to show all the analysis that gives us that conclusion. All right. So I feel like this is one you guys should be okay with on your own. So I'll give you about 4 or 5 minutes. And then we will come back to this and talk about it together. Sound good?
Mm-hmm.
All right, go for it. So let's think about what we need to do here. First off, we're looking at tangent lines. So that means we need to find a derivative. And we also need to look at tangent lines at the x-intercepts. So first thing we might need to do then is just figure out what are the x-intercepts and how do you find the x-intercept of any equation.
Plug in y equals 0.
Exactly. So we'll put in y equals 0, which will give us x squared plus 0 equals 27. Right? X-intercepts are when y is 0. So x squared equals 27, or x equals positive or negative root 27, which we could write as 3 root 3. Good or no?
Good.
All right. Then we need to look at the tangent lines to the curve at those points. So those 2 points are 3 root 3 comma what? 0? And negative 3 root 3 comma 0. So in order to write tangent line equations, we need 2 things. We need a point and we need a slope. So we got the points, we just need to find the slopes. So what we'll do is we'll go in and we will take the derivative of x squared plus xy plus y squared equals 27. And how will we take that derivative?
Implicit differentiation.
Exactly. Implicit differentiation, because we have x's and y's in there, and we need to differentiate with respect to x. So the x squared becomes just 2x. The xy, that one we should be pretty used to. We've done xy itself a bunch of times, but it's x derivative of y, so x dy dx, plus y times the derivative of x, and then plus 2y dx equals 0. Good or no? Is that what you all got on your first step of finding the derivative there?
Yes.
All right. So then you probably brought the negative, or the 2x and the y to the other side and made them negative 2x and minus y, and then divided by x plus 2y. Is that what everybody got for the derivative?
Yeah.
Perfect. So then all we have to do is we have to evaluate that at the 2 points that we're looking at, 3 root 3, 0, and negative 3 root 3, 0. And if the tangent lines are parallel, then what will we find when we evaluated at both of those points?
It should be equal.
Should be equal to each other. So 3 root 3 comma 0 should be what?
-2.
So negative 2 times 3 root 3, which would be negative 6 root 3, right? Minus the 0 over 3 root 3, which gives us what?
-2.
Negative 2. Perfect. Okay. And the negative 3 root 3 comma 0 should give us negative 2 times negative 3 root 3, which is 6 root 3 over negative 3 root 3, which is also negative 2. These are the same, and so they are parallel. Any questions on that? Everybody good? All right. Now we're going to move back to this other one here. This one is a full free response question. This would be worth 9 total points. And this one, a graphing calculator is required for it. You will need a graphing calculator to get some of these values. So most of the instructions here, coming down here, are the generic instructions that you would normally see for any graphing calculator problem on the AP test. But it's good to take a look at it now and get used to it. And then we've got 4 different parts, A, B, C, and D down here. Some of them will be pretty easy, I hope, for you. Like part A should be pretty easy. Part C you might do okay with. Parts B and D, I feel like you might have a little more difficulty with. So I'm going to give you guys a full 15 minutes, but I'll check in after part of the time and make sure that like people are still working, because some of you may just end up sitting there and staring blankly at it, which is okay because we haven't done anything quite like this yet. And if that's the case, if everybody just is ready halfway through to start talking about it, we'll just do that. Sound good? Hopefully everybody was successfully able to do part A. Now, part A is asking you for the second derivative of f evaluated at e to the 1.5 power. Now, this is a calculator question, and it asks us to express our answer as a decimal, so we know that we're going to need to use our calculator to evaluate this. We have 2 options. The first option is we can actually take the derivative of x times sine of x squared, write it out explicitly, and then plug in e to the 1.5 power. But since this is a calculator question, the easier option is just to use our graphing calculator and go into the math window, go to option 8, which is your inderiv, and just type in your function, which was, I believe, now I forgot, was it x, and then sine of x squared? Is that right? X sine of x squared?
That's right.
Okay. All right, so x sine of x squared, and we're evaluating that at x equals e to the 1.5. Make sure that you're in radians for this, but that's all you've got to do. Hit enter, and you get 14.144. So if this was the test, like the AP test, you'd write something like the derivative with respect to x of x sine of x squared evaluated at x equals e to the 1.5 is approximately equal to, what was it, 14 point, I forgot what it was, 14 point something, 144. And that's it for part A. Easy enough. Any questions on part A? All right, so for part B, we're looking at a new function, h. And h is defined as f of g of 3x. So we've got h of x is f of g of 3x, and we want to find h prime of 0. So we're looking for the derivative of this function, f of g of 3x. And f of g of 3x is a composite of two different functions, isn't it? We can say that h of x is equal to f of u with u equal to g of 3x. Do you guys agree with that?
Yes.
Okay. And what is u? U is also a composite, right? U is equal to g of another function. We'll call it v, with v equal to 3x. Everybody good with that?
Yes.
All right. So what's the derivative of f of u? It should be f prime of u, and then times the derivative of u. And to find the derivative of u, we'll do this, g of v. So that'd be g prime of v, and then times the derivative of v, which is 3. So that's just the chain rule within the chain rule. And you probably, hopefully, recall that one of our ways that we wrote out the chain rule was the derivative of f of g of x is f prime of g of x times g prime of x. And that's exactly what we've done here. We've done f prime of g of x, right? F prime of g of 3x times the derivative of g, which was 3 times g prime of 3x. Everybody good with that or no? So this is just the chain rule within the chain rule on some functions that we don't actually have an explicitly written out function, but we're still using the same rule. Does that make sense or no?
That makes sense.
Okay. You're going to need to get used to this because a lot of questions on the AP test end up being like these conceptual types, which is why we're going to start looking at some of them now. So if we want h prime of 0, h prime of 0 ought to be f prime of g of 0 times g prime of 0 all times 3. And how are we going to evaluate that? Well, this becomes f prime of something. What's g of 0? How do we find g of 0? just head back to our chart that we had. What's g of 0?
4.
4. So this is now f prime of 4. And g prime of 0, we were just at it, g prime of 0 is negative 7. So this is f prime of 4 times negative 7 times 3. Or negative 21 times f prime of 4. And f prime was x sine of x squared. So we end up with negative 84 sine of 16. And I think it asks us to do this in terms of a decimal, right? So what was it? Negative 84. Negative, why did we keep doing it? Negative 84, there we go. Negative 84 times the sine of 16. And that comes out to be 24.184. Everybody good with that? Any questions on that process? All right. Let's move on to the next part. So part C, we want to write an equation for the line tangent to G inverse at the point where x equals negative 1. So what rule do you think we're going to use for part C here?
Inverse rule.
The inverse rule. So we're talking about G inverse when x is negative 1. So I'm going to first write out G inverse, and it's going to have a point when x is negative 1. What does that tell you about G, which is the inverse of G inverse? It's got to have a point where what is true?
Y is -1.
Or y is negative 1. And so G inverse prime at negative 1 should be 1 over G prime at whatever value we find here for G. So when does G of x equal negative 1? Well, we go back to our chart. G of x should equal negative 1 when x is 2. Everybody see that?
Yes.
All right, so this is 2, this is 2, and this is 2. So the question we're trying to find is the derivative of the inverse of G at negative 1. It should be 1 over G prime of 2. And once again, we'll just go back and look at the chart. G prime of 2 is negative 3. So this is 1 over negative 3, negative 1/3. And we're not asked for the slope, we're actually asked for the equation of the tangent line. And so how do we write the equation of the tangent line for G inverse at negative 1? What is the point we're going to use? We're going to use this point, or are we going to use this point?
The point for the inverse?
The point for the inverse. We're going to use G inverse. So that's the point negative 1, 2. Y minus 2 equals negative 1/3 times x minus negative 1, or x plus 1. And that's part C. Any questions on that? All right, one part to go. So the last part of this is talking about a point 1, 4 that lies on the on the curve that is given by this equation, f of x plus g of x squared equals xy. We want to find dy dx at 1, 4 using a decimal. So we're going to talk about this new equation, f of x plus the full function g of x squared equals xy. Everybody good with that to start with?
Yes.
All right. So in order to find dy dx, this is an implicitly defined equation. So we're going to want to use implicit differentiation and differentiate each side with respect to x. So what's the derivative of f of x with respect to x?
X sine of x squared.
Say that again?
It's x sine of x squared.
Oh, x sine of x squared, right? It's f prime of x, right? It's the derivative of f, which, yeah, I'll replace it with the x sine of x squared once we get through the whole derivative. All right, back from here, it's f prime of x, which is x sine of x squared. Good. Okay, and then what about the derivative of g of x to the second power? If I take the derivative with respect to x, this is a function in terms of x, so it's a u squared, right? This is, put this over here, this is u squared with u equal to g of x. So that should become 2u, or 2g of x times g prime of x. Good or no? 2u, which is 2g of x, and then the derivative of u, which is g prime of x. Any questions on that part? And the xy we've done a bunch of times. We just did it earlier in one of the other problems. X dy dx plus y. Good or no? Hopefully that's all right. So dy dx should be equal to all of this. Right? F prime of x plus 2g of x g prime of x minus the y, all divided by x. Everybody agree that that's dy dx?
Yes.
Anybody have any issues with that so far?
Can you go over again how you got 2g of x, g prime of x from the g of x squared?
Yeah, so g of x squared is a composition of two functions. It's u squared with u equal to g of x. Good with that or no? That it's u squared with u equal to g of x?
Yeah.
So the derivative of u squared is 2u, and the derivative of g of x is g prime of x. So it's 2u, and u is g of x, so that's 2g of x, and then g prime of x.
Oh, got it. Okay, thank you.
Yep. All right, and then so what are we going to evaluate this at? We're going to evaluate this at the point 1, was it 1 comma 4, I think? So we're looking for f prime of 1, and we know what f prime is. F prime is x sine of x squared, so that should be 1 sine of 1 squared plus 2 g of 1, g prime of 1, minus our y value of 4, all divided by 1. So far, good? One times the sine of 1 squared is just the sine of 1. And then we got plus 2 times g of 1. And if we go back here, g of 1 should be 2, and g prime of 1 should be negative 2. So g of 1, so we got 2 times negative 2, and then that minus 4, and then all over 1, we can ignore the all over 1. We get the sine of 1 minus 8 minus 4 or minus 12. And our graphing calculator, or any calculator for that matter, will be able to tell us what that is. The sine of 1 minus 12, negative 11.159. And make sure you always round to 3 decimals or more. Any questions on that? For those of you that were floundering with it at the beginning and struggling, does that make more sense now? Does that seem a little easier?
Yeah, it does.
It may not seem super easy yet, but by the time you take the AP test, we'll have done 15, 20 problems very similar to this. And if one shows up, you should be good with it. And last year on the AP test, things were far more conceptual than they were like, actually by hand taking derivatives and all of that, because there's plenty of ways to cheat on just taking derivatives, but it's a lot harder on, an AP test where nobody's really actually watching you because you're doing it from your house. It's a lot, lot harder to cheat on something like this problem rather than if I just said, oh, f of x is this, g of x is this, find the derivatives of them, So if we don't end up having an in-person AP test, expect lots more stuff similar to this.